As noted, I'll be just giving kind of an overview of SPU and King County's Ship Canal Water Quality Project. I'll give a little background on Seattle Public Utilities, an overview of the project, and then talk in a little more detail on two of the bigger elements of the project, which is the storage tunnel and our pump station and Ballard conveyance project. And if you guys are still awake, we have time for the end of questions. So Seattle Public Utilities, we are a department of the City of Seattle. We provide drainage, wastewater, drinking water, and solid waste services. And we have about 1,400 employees. For this team, for the Ship Canal Water Quality Project, these are the key team members. King County and SPU are the co-owners on the project. I'll explain about why that is a little bit later. In the middle row, we've got our prime consultants that are doing design, and I initially thought about trying to add all the sub-consultants, but I would have needed several slides. There are a lot of sub-consultants, a lot of people doing a lot of good work on this project. And the bottom row is our prime contractors for our construction projects. And again, lots of subcontractors under them. So to talk about what this project is and why we're doing it, we'll look at history. So these two pictures are from the 1930s in Ballard, where one of the places we're working in the Ship Canal Water Quality Project. And it shows putting in the city's sewer system. And you can see down at the bottom, got like old wood stave pipes that are just going right out to the water. The key is that we may have replaced those wood stave pipes, but really we're using the same pipe network where sewage from homes and buildings and stormwater runoff are going into the same pipes. And that creates a problem that I'll show in the next slide. But back in the day, that is called the combined sewer, where we've got sewage and stormwater in one pipe. Back in the day, dilution was the solution to pollution. So just send it in the lakes and receiving waters, which was kind of typical for the era. And as I mentioned, so we're still using that. And the problem is that now we've paved over everything and we built impervious surfaces everywhere. So the system works on a dry day, but when we get a decent rain, there's just too much flow that overwhelms the system. So this map shows the older parts of the city where we have combined sewer systems. And each of the red dots is an overflow location for the combined sewer system. We are, as you'll see in later slides, we're working kind of along here on the Ship Canal, but you can see that there are overflow points all around the city. So this is what I was mentioning earlier. On a dry day, the sewer system, the pipe network can handle the flow. And on a rainy day, it can't. And so the old pipes that used to just go straight out to the water, those are kept as overflows. And you can see here why they're needed. If we had just eliminated them when the sewer system was over capacity, we'd have backups at the low points in people's basements or in roadways. So we need to keep these overflow locations, but we have to reduce the volume and frequency of overflows. It's important to note that the problem isn't downstream at the wastewater treatment plant. This sewer network, we couldn't get the flows to the treatment plant without redoing the whole system and probably ripping up every street to separate out, put in new pipes to handle stormwater, make every homeowner replumb put in new pipes to take the stormwater to a different pipe. So it's just not feasible as an option to do that. So for the Ship Canal Water Quality Project, mentioned on the Ship Canal and Lake Union is where we're working. And I don't know how old this graphic is, but it shows sampling for fecal coliforms. And obviously this was after we had an overflow event, but this area is kind of the biggest offender in the city as far as overflow volume. And it's not in Puget Sound. It doesn't get tidal flushing. So we um, get coliforms and other things in these waters. And these are waters where people are kayaking and paddleboarding and swimming. So it is important to clean this up. And that's why amongst our team, I refer to our project as a public health project because of this, because these are water bodies it's not just theoretical contamination, like these are used by people. So this is what our project is going to do. We will end up building a storage tank in the form of a tunnel. And when the sewer system is over capacity, instead of going all the way to the outfall, we will intercept. Actually, if you guys could mute, if you're maybe just mute, that'd be a good call. Thank you. So we'll intercept the flows, we'll store them temporarily in this tank, and then after a storm has passed and there's capacity in the sewer system again, and at the treatment plant, we will pump the flows out and they'll go to the treatment plant, get treated before they get discharged. So one question is, we're in the city of Seattle working on sewer system, like why is King County involved? So a little history on that. I mentioned earlier that the original pipe network used the dilution principle with, in my very, very limited research, there were some places that had limited treatment that was probably just sedimentation. But Lake Union, Lake Washington you can only keep discharging into those water bodies until it all kind of catches up. And so they got really disgusting and the public noticed, and there was a public campaign to do something about it and form a new agency called Metro. And in fact, this is actually a flyer for a public vote to try to urge people to vote to tax ourselves and form this new agency that will replumb the city, will build new interceptor sewers and take all the flow to some new treatment plants. And so it happened. So Metro was formed in 1958, did all that work. In 1994, Metro became King County Wastewater Treatment Division. And so to take a step back, King County in the region, they run the regional wastewater treatment plants. They have one at West Point in Magnolia, South Point in Renton. They've since built Brightwater up north, and they've got a couple other smaller ones. But many of the local municipalities, including the city of Seattle, we collect sewage and convey it, hand it off to King County, and we pay King County to treat it. So all of that still begs the question, why is King County involved in the Ship Canal Water Quality Project? So this I don't understand as well, but when Metro was formed in 1958 or maybe sometime after, there was an agreement that very large sewer basins within the city of Seattle, I think it's basins over 1,000 acres, are the responsibility of King County. So even though they're within the city limits, they're responsible, or King County is responsible for them. So that means SPU has combined sewer overflows. SPU, my agency, has combined sewer overflows in the city, but King County does as well. Which brings us to how this project started. So before I go through the text, this map at the right shows the contributing areas, the basins that contribute to the Ship Canal Water Quality Project. And you can note that King Counties are the green basins, which are very large compared to the pink City of Seattle basins. And that is the last slide kind of explains why. So the Ship Canal Water Quality Project is a regulatory requirement. In 2013, both the City of Seattle and King County signed a consent decree with the US EPA, the Department of Justice, and the Washington Department of Ecology to bring our combined sewer networks into regulatory compliance. In Washington, regulatory compliance means this middle bullet here. You're allowed to keep all the overflow points, but they can only overflow at most once per year on a rolling 20-year average. And then the consent decree was modified in 2016 to acknowledge that we're going to do this joint project together. And then just last month, there was another modification of the consent decree, which, among other things, pushed out the required end date for the Ship Canal Water Quality Project from the end of 2025 to the end of 2027. And then to jump back to the top, so when this project's done and we're storing flow instead of overflowing, modeling shows that we will reduce the volume of combined sewage overflowed into Lake Union and the Ship Canal by 75 million gallons per year. And then the other details, the Ship Canal Water Quality Project will bring 4 City of Seattle outfalls and 2 King County outfalls into compliance. You can see some details on the cost share, and the overall budget is $710 million. This is just another look at kind of the general area that the contributing area and where the project is located. So to build this new facility, we've created this program and broke it up into 4 main construction contracts. And you can see the progress we've made here on the schedule. So the top project, the Ballard Early Work Project, it was largely a site remediation contract at our Ballard site. We also did some other work like moving utilities and bringing in a very, very large power supply to power the future tunnel boring machine. So Ballard Early Work was almost like a site prep contract to get everything ready for the storage tunnel. And then the storage tunnel contract started in 2020 and should finish this summer. At the bottom, we have the Wallingford Conveyance Project, and I'll show these all on a map to hopefully make them make a little more sense. But that contract was finished earlier this year, and then now soon we will have 1 contract left, which is our pump station and Ballard Conveyance contract, which will kind of bring the overall facility on board right at the end of 2027. And this is a map showing the whole facility. So the tunnel itself, instead of being a concrete box, it's just a long cylindrical storage tank. It started in Ballard, and our tunnel boring machine went largely through city right-of-way, all the way over to Wallingford. The tunnel itself is 2.7 miles long, has an internal diameter of 18 feet 10 inches, and can store just under 30 million gallons of flow. The 18-foot 10-inch diameter dimension was intentional because that matches the typical transit, the size of a transit tunneling machine. So all of the Sound Transit tunneling machines have been 18-foot 10 inches in diameter. The goal was to allow contractors to potentially reuse a machine they may already have, because that's a common size. So the storage tunnel project, so it built the tunnel, and then at each of these neighborhoods, it also built conveyance pipes and hydraulic structures to intercept flow and direct them into the tank. In Queen Anne, we actually had an 8-foot diameter tunnel that went underneath the Ship Canal to bring flows from Queen Anne into the storage facility. And I mentioned we had other construction contracts. So that Wallingford Conveyance contract I mentioned, that I got muted. I don't know how long I've been muted.
No, you're all good.
It was,
Sorry about
it
that.
was only a few seconds. Don't worry,
Okay.
Alan. It was only a few seconds.
Great, thanks. The Wallingford Conveyance contract it built a hydraulic structure to intercept flow and a pipeline in Ballard in Wallingford to bring flows into the storage tunnel. And then the last project I mentioned that is ongoing now is building the pump station that will drain the storage facility and a 60-inch diameter conveyance line to bring flows from Ballard into the storage facility. This is what the facility will look like in profile. So the pump station is in Ballard because the whole tunnel is sloping to drain that way. Everything that's dark blue is being built or was built by the storage tunnel contract. So the tunnel, all the drop shafts, and the conveyance piping and structures to get flow to the tunnel. The orange was our Wallingford conveyance contract, and then the green is the Ballard pump station and Ballard conveyance contract. It's kind of interesting to note that we're spending a ton of money, $700 million. And when we're done, there will be a building, above grade building in Ballard, and then a tiny little one in Wallingford that you'll see. And that's it. Everything else is underground. So in theory, the public will hopefully not ever really see this or know what we did. And here's just a couple examples of what these drop shafts and below grade structures looked like, or look like, not in the past tense. The mechanical electrical vault has odor control on the mechanical side. It's just a carbon bed that air is going through. And then we've got an electrical room over here. And this is the Fremont drop shaft, which is the most complicated. You'll see this again, and I'll explain it again, but here we have the 8-foot diameter tunnel coming in to bring flows from Queen Anne. There's also flows coming in from the local Fremont neighborhood. And then we have a little horizontal tunnel to actually connect to the big storage tank. And then odor control and other HVAC type stuff in there. And now I'm going to show you just some construction pictures from the storage tunnel for each of the 5 neighborhoods. So this is probably a year ago, maybe more than a year ago in Ballard when tunneling was underway. So to help orient you, Market Street is just off the screen or just off the picture on this side. This is 24th Avenue Northwest. And if any of you know or old like me, right here is the old Yankee Diner restaurant that we are now using as a construction office. Back when I was in college, we used to have ASCE meetings at the Yankee Diner restaurant, and now it's our construction office, which just seems kind of ironic. But this is the shaft where our tunnel boring machine was launched from. And you can see I've tried to fake in here how the tunnel alignment from that shaft. I'll talk more about this later, but you can see there are 2 gantry cranes here, and one of them is dedicated to just bringing supplies down into the shaft to support tunneling that's happening well beyond here. And then this other gantry crane has a clamshell bucket on it, and its job is to pick up the soils that are coming back from the tunnel, put them in this holding tank, and then they get loaded into trucks and taken away. This is an incredibly small site for a tunnel of this size, and the whole thing is just a logistics operation of just-in-time deliveries to make sure we don't run out of tunnel segment liners and we can get all the soil taken away in time, because if this holding tank fills up, then we got to stop tunneling because we got nowhere else to put the soil. So tunneling project this was my first. It was very interesting. So moving from west to east, this is what we call our East Ballard neighborhood. To help orient you, this parking lot is the Fred Meyer parking lot in between Fremont and Ballard. So there's an existing pipe here. It's King County's outfall pipe. So we're intercepting the flow, and this is the same schematic down here. We take it this way, it goes to a drop structure, and then we have another little horizontal tunnel called an adit to get the flow into the storage facility. And then the big dashed red box is that mechanical electrical vault we saw earlier. And this is just a schematic of kind of the same thing. If we go over to Fremont, this is the busiest site. So you can see where the big storage tunnel goes right down the street. downtown Fremont is just right off the picture here. Another horizontal, this is, I guess, the same one we saw before, a little horizontal tunnel I kind of faked in to show the connection. We've got the 8-foot diameter tunnel coming in from Queen Anne to bring flows in. We've got local Fremont flows. This big vault over here is another of the exact same mechanical electrical vault. And then on the right, got some pictures in construction. So looking down in the shaft, you can see this pipe and this pipe are the pipes coming over from Queen Anne. So they function as a siphon. And then we have pumps here to drain them after the storm event's passed, because we don't want the siphon pipes sitting full of water and having solids settle out. And then much later in time, this is one of the upper floors that has all the other equipment and associated stuff in there. This is a 3D rendering of the same thing, of the Fremont shaft. So flows from Queen Anne kind of come up on this white pipe, and then they come up here, get dumped through the wall and into the tunnel. You can't quite see it, but the Fremont flows, I think, come behind the wall here and get dumped down and in here. And the yellow piping is all odor control ducting to go off to the odor control system. And then we've got some pumps and other sort of hoisting systems, but that's about it. And then we've got our Queen Anne site. So this is the Ship Canal bike trail here. Seattle Pacific University is just off the screen this way. So we intercepted an outfall where there's buried piping here to take flow into this drop structure. It drops down, goes under the water, and you can actually see the Fremont site just across the water here. And then this is what it looked like before it was all filled in, but these are the 2 siphon pipes that will go under the Ship Canal and show up in Fremont. And then at the furthest east end, we've got our Wallingford site. This is where the tunnel ends. So the tunnel boring machine was removed from here. It has a drop shaft, flows. I'll show you the next slide, but flows come in from the Wallingford neighborhood here and drop down. This rectangle here is an odor control system. And then this is the foundation for the only other above grade building, our electrical building, which is this black building here. And then these 2 photos on the right are what it looks like, I think, a week or 2 ago. So it's very much nearing completion. This photo on the bottom is standing on the roof of the building while we were doing an inspection. And so you can see we're onto like landscaping and putting up fencing and stuff. So we will finally be done this summer, thank goodness. So that was a bit of an overview, and I wanted to talk a bit about the storage tunnel project and then a little bit about the TEPS and we interchangeably call it the Ballard Pump Station or TEPS. TEPS stands for Tunnel Effluent Pump Station. We kind of got ourselves into using one name for the public and the other name in-house, and then we'll have a third name when it's actually built. So sorry if I say TEPS, it's just the pump station. So this is a picture of our tunnel, and I mentioned earlier, the whole thing is just a logistics operation. These are the trains that run materials back and forth from the shaft to the front where they're actually mining the tunnel. And everything that you see here is temporary. As the tunnel advances, they have to advance all of these pipes and keep building the pipes to bring grout and chemicals and water up to the front. This big duct here, this air duct to bring fresh air in. They've got to advance the electricity and the lighting. They've got cell phone repeaters so we can have a cell phone system. Even the railroad tracks, as the tunnel machine moves forward, they're building railroad tracks right behind it. And then when the tunnel finishes, they take all of this stuff out for 2.7 miles, and they have to plug every single hole that they have to mount all this stuff. It is an amazing amount of work to build a tunnel. So the storage tunnel project, construction started in January of 2020. Mudhoney, our tunnel boring machine, was launched in August of 21, and it broke through in Wallingford in June of 23. And so we see pictures here on the right. So Mudhoney with the fancy paint job before it launched. And then this is what it looked like when it came out. And there is a little bit of red paint way back there. The 8-foot diameter tunnel boring machine that went under the ship canal also came through in 2023, so that was a big year for us. And as you kind of saw in some of those pictures, where we're at now, we're doing testing and commissioning of the electrical and mechanical equipment, and then the contractor is doing site restoration work. And we should be done in a month or two this summer. So to talk a little bit more about tunneling, I think most of us, myself included, when we think of a tunneling or a tunnel boring machine, we think of this front part, the shield, and then the cutter head, which is the spinning bit here. But the tunnel machine actually pulls behind it, depending on the project, a series of kind of like train cars that are called gantries. I can't remember now if we had 11 or 14 gantries that were being pulled behind, but they have all the support equipment that we'll see in a second. And this on the right is a picture of the contractor did not reuse a tunnel boring machine. They bought a brand new one from Heron Connect, which is a like the Mercedes-Benz manufacturer of tunnel boring machines from Germany. So they custom built this whole machine and all the gantries in Germany, and this is a picture of that. And then they disassembled everything and sent it on ships through the Panama Canal. It showed up in Seattle, and everything had to be reassembled and completely retested. It's quite the operation. And on the left here, I wanted to show a little bit of how tunneling works. So the cutter head at the front spins, and then the soil gets dumped into a void space behind it. And then for our machine, there was like an Archimedes screw here that picked up the soil and took it onto a conveyor belt that ended up taking it back, and then that's where it gets dumped into the train cars and then taken back out to the shaft. And the way the tunnel boring machine advances is all around the circumference, they have these hydraulic jacks or rams that push off of the already built tunnel. And so they push forward and then they retract. And in the space that they retracted, the crew will build another ring of pipe using segmental liners, just concrete, reinforced concrete system. And then they just do it the same. They keep doing it over and over like an inchworm. And that's shown a bit here as well. So this is a profile of our actual tunnel boring machine as it was built. So soil comes into this void space. This is that Archimedes screw I was talking about. And then it dumps the soil onto this conveyor, which goes overhead. And you can see there's train tracks here. So the train backs up and dumps the soil in there. And then when the train is coming here, it also brings the liner segments to build more rings of pipe. So those get offloaded. And then there's another kind of moving belt here, and they get picked up moved to the front, and you construct your rings there. And you can see all the gantries here, not all of them, just the first 4. But like this yellow box is the operator's headquarters. They have like power supplies and chemical storage, mixing pumps. They have an emergency shelter in there that can house, I think it was 12 or 15 people for 24 hours in case there's a fire in the tunnel. There's just an amazing amount of stuff on these cars. And then if we look at the kind of a section cut through here at number 2, which is here, you can see that the gantries have a big hollow void space in them. So up here, it's to let the tunnel segment liners be moved forward. But if we look back at the section number 1, there's this big section to allow the train to be moving back and forth in between the gantries. And yeah, you can see the train tracks, like all of this stuff, as I mentioned earlier, just has to get extended. Every time the tunnel moves, you got to extend the train tracks and extend the pipes and all that stuff. And so this is more on the logistics, but the top here, you can see how the train is organized. The locomotives here going this way. It's got these muck bins to take the soil away. And then at the front, it's got the tunnel segment liners and other materials like train tracks that they need to get up to the crew. And then passengers ride way back here. So I already talked through kind of the logistics of the site here and what these cranes are for. This is one of the trains going in the tunnel, and you can see this is the front end of the tunnel because it's got the tunnel segment liners. And this is a crew. There was a crew that did nothing but build train tracks behind that tunnel boring machine until the machine was finished, and then they turned around and started disassembling all the train tracks. And this is kind of the tunneling in action. So this picture on the left is from the very back of the gantries. This is the locomotive, or I guess the passenger car of the train. So all the muck cars and everything else is forward, and the tunnel, the cutter head and everything is kind of out of the screen ahead here. And then this is this is what the muck bins look like when they're taking the soil away. They have to add a bunch of soil conditioners to the soil, and their goal is to make it about the consistency of toothpaste. And then the other thing I want to point out is these red lights that you see in both pictures. It's really loud there, and because that train operator is backing up and they can't see, they installed those lights as a kind of belt and suspenders communication system. They have a radio that tells someone on the gantries is telling the train operator, okay, you can back up. But we actually did have a safety incident, and so they added the red lights too. So if the lights are red, whether they can hear on the radio or not, they got to stop and wait till the lights are green. And then this is the crew building another ring of the tunnel. So after the liner segments get moved by the conveyor belt up here, there's this arm that picks them up, and these things are, I mean, they're solid concrete. They're very heavy. I don't know how heavy, but it picks them up using vacuums, which is kind of amazing me, and then it'll just rotate them around. Obviously, this guy's got a control panel, put them in place, and then these guys get it kind of seated in there, get the next one, and they just got to keep everything moving because you don't want to slow down the system. And then this is Mudhoney when it's coming out in Wallingford. So you can see that the shaft was flooded, and that's relatively common. You want to equalize the water level with groundwater level on the outside of the shaft, because you don't want, when the machine breaks through, you don't want groundwater rushing in and potentially causing settlement around here. So the machine came in underwater. And then the shaft is pretty small actually for the machine. So Mudhoney, our tunnel boring machine, had to be removed in pieces, as you can see here, over a series of weeks. And here you can see the shield with the steel cylinder around it. And then on the right, they even took that off. It started taking off all the internals piece by piece. So quite the operation just to build a tunnel. And then I mentioned we had some horizontal connector tunnels at two of our shafts that are called adits. So after we finished building the tunnel, and after they got all the piping and train tracks stripped away far enough, it's kind of crazy. Then they just started breaking the tunnel, just started breaking it open and digging through, like, pretty much manually between the shaft and the tunnel. And then they had to bring in a ton of rebar and shotcreted this whole thing up. I think there's one more. There we go. Bringing these crazy custom forms and create these concrete horizontal connector tunnels. So that was a summary of the storage tunnel project. I thought I'd give one slide on the Wallingford conveyance project. So on the left, you can see in a little better detail the alignment. So the outfall goes straight down Stoneway and out to the water. We built a structure to intercept the flow and then take it back by gravity into the Wallingford shaft, the same shaft where Mudhoney was removed. This dark green is the big storage tunnel. This was a much smaller contract. This one was it was bid at a little over 8 million, I think. The storage tunnel bid was 255. But this was a very tough project. We had to shut down a block of Stoneway for over a year, all kinds of traffic detours and parking restrictions and things. And also, this pipe is going downhill by gravity here against grade. So this got to be a very deep excavation and trench to get it in here. There's just a picture of it being built. But that was finished in about February of this year. So that one's done. And then the last project, the pump station and Ballard conveyance project. So it's two main elements. We're building a pump station in the same shaft where Mudhoney was launched from. I have more pictures of that. And then we've got 60-inch pipe that will be installed by microtunnel to get flows into the storage facility. So the microtunnel with the finished pipe will be about 2,000 feet of 60-inch diameter pipe. The pump station will pump at 12 MGD max, so it would drain the whole facility in 2.5 days. And as I showed earlier, we're forecasting to be construction complete right at the end of 2027. This is a rendering of what the pump station site would look like. So one of our few facilities that actually has like an architectural element to it. So we've got this architectural lattice, and it'll have a lighting system on it. This is the old Yankee Diner restaurant that we're using as a construction office. Don't know what'll happen to that long term. We're also rebuilding the street end here to make, and that was sort of a permitting requirement, but more of a pedestrian experience and a better shoreline with kayak and hand launch boat systems and stuff. And over here you can see a section cut of the pump station. The most unique thing is that the wet well is the outer ring, or sort of the donut ring here. The dry well is this cylinder in the middle. One advantage of that is we don't have to worry really about controlling leakage through the wall, because it'll go in the wet well and it'll just get pumped out, and probably be good to exercise the pumps a little bit more. So we've got 3 pumps on the bottom level. We've got space for future pumps. We've got an odor control system here, drive-through access with large vaults here, a lot of electrical stuff here, and I think down here, and HVAC on the roof. I think that's about it. Here's some pictures of what has happened so far in the pump station project. This is all the same shaft in Ballard that Mudhoney, the tunnel boring machine, launched from. We intentionally had the storage tunnel contractor not build the full finished wall of the outer ring, because we wanted the Ballard conveyance contractor to be able to coordinate wall penetrations for the pipes that need to come through. So they did that. They ton of rebar here. They poured all the concrete here, and that is all done. And then on the bottom right, you can see they've now moved on to that inner cylinder. And just like a high-rise downtown, they've got a slip form where they're just pouring it, sliding the forms up, and advancing that that cylinder up. They will be doing that for the rest of the year. And then this is my last slide, and I'm guessing many of you are engineers, so you might appreciate this. This is how engineers have fun. So because the storage tunnel is running long, in our construction office, we're housing our staff and contractor staff. And so we now have our staff, storage tunnel staff, and pump station contractor staff. And the storage tunnel, I might back up here a second. I'd have to go a ways. So the storage tunnel, one of the things that they're building at each one of these sites is they have to have an isolation gate. So when the storage tunnel is full, they close this gate so flows cannot keep coming in. And they have to leak test those gates. So the storage tunnel contractor needed to leak test the Wallingford gate, like the furthest one away. The problem is the Ballard pump station contractor is working in this shaft, and as soon as they release the water, it's going to go through the tunnel and show up in Ballard. So the contractors were able to work together, and we ended up having a rubber ducky race for this leakage test. So Flatiron, the pump station contractor, had a duck. Lane, the tunnel contractor, had one. The owners got one. Jacobs from the construction management team got one. And then the design team created their own rubber duck. And then I've got a video of them showing up in the Ballard shaft. And again, this is as good as it gets for engineering entertainment. You can hear the excitement. And that's pretty much it. But these are the results, and I'm proud to say that at least the owners got second place, which is, we'll take that. And that is all I've got. So now would be a great time if anyone's got questions. I'd say just unmute and just ask. No one?
So thank you, Alan, for the great presentation here. I think we should be able to stop the recording now. I still see it going. And leave